There are two different addition rules for probability that we're going to see here in this video. And the first rule has to do with when two events, A or B, are mutually exclusive. So mutually exclusive means that there's nothing in the intersection. A and B don't share anything at all. So the circle A doesn't, technically, even though it's drawn as overlapping, I mean, you can think of it, it's probably easiest to think of it as there is nothing in the overlap of the circle for event A and the circle for event B, all right? So here we can write out what the probability of each event is. So the probability of A, remember the theoretical probability is the number of outcomes in that event out of the total number of outcomes. So all of the outcomes in the universal set, which is the rectangle, is all three of the numbers added up. Well, I guess there's a 0 in there, but we don't have to add 0. So this is 16 out of 40, and I'm just going to leave it like that. I'm not going to simplify it, but I will go ahead and write the probability of A equals 16 out of 40. And the total's the same, right? Like I could have calculated it on the side, right? So the total outcomes is 16 plus 18 plus 6 equals 40. Right, so the probability of B is just going to be the 18 elements in B out of the total 40. And so I'm just going to leave those right there. So if I need to find the probability of A or B, it's just as simple as adding up the probabilities of each of them. So A or B just means we're considering the probability of the events in either of them. So it's all of these events. Now we can just do that by adding up the events, but if we use this rule up here, we're going to add the probability of A plus the probability of B, and that is 16 out of 40 plus 18 out of 40. And that's really, since they have the common denominator, we just add them up. So that should be 34 out of 40 is the probability of A or B. If we had done it, just because we can visualize all this, so this is the other way to do it in this case. I can't spell. Another way to do this would just be to observe that like I explained, the probability of A or B means that the number of elements in A or B is 16 plus 18 out of 40. So again, that's 34 out of 40. So if the two events are mutually exclusive, you can usually choose either option, right? So I wanted to show you using the rule though. All right,